I don't know if we'll finish these notes today, but we'll try.
I think we will. Oh, we get out of here. 30 seconds, right?
Just laying on that desk right there.
Actually, I need a copy.
Yeah. Looks like I left my pen at home.
I didn't even get the homework. Check the phone.
That was actually the first time I think I had to pass something out.
It's the second time.
Was
First time
it?
you set on fire too.
I didn't, did I?
Time, you know.
Should have two things. You should have a homework assignment and a copy of notes. Everybody got that? This is the beginning of logarithms.
Oh, no. Let's set this one out there. Got it.
You don't want to sit this one out. First off, hey, up here, I ain't got time to goof around. Can you answer a question like this without a calculator? If 3 to the x is 27, what is x? 3. Most people can. Most people can answer questions like that because 3 cubed is what? It's 27. So x is 3. How about if 4 to the x is 256, what is x? 4 is correct.
I mean, I can't do this fast as her.
You can answer stuff like that without systems technology. It's not that hard to do. But can anybody tell me what value of x generates a 509? You're all making things up. You could sit there and punch buttons on your calculator all day long, you'd never get it. Huh? 4 to the 7th, if 4 to the 4th was 256, 4 to the 5th alone was 1,024. It's a little over 4, not much over 4. Anyways, we're not going to sit here and push buttons all day. Okay? That's not the whole point, is to not have to do that crap. We rewrite that as a logarithm. Mathematicians define that as x is a log base 4 of 509. I'll show you that. This is actually what x is. Log. If you look underneath x squared, you'll find it. I'll zoom out so you can see more of my keypad here. Log's right under x squared. Now, they actually have a base 4. You're not ready to know how to do that yet. Never mind. Can't show you yet. Your base on your calculator is base 10. But we'll get to that today. Anyways, key concept day, definition of a logarithm. I've got b and a. Let b and a be positive numbers with b not equal 1. The logarithm of a with base b is denoted by log base b of a and is defined as follows. The logarithm of base b, argument a, I use that right there as to note equivalent, is equivalent to b equals a. And this should have an equal sign to an e here. So log base b argument a equal to sum e is equivalent to b to the equal a. This whole log is bay thing. Been using this for years. When I taught it, Miss Buckley used logarithm base x argument y equal to r. One of the best math teachers ever.
She's scared.
If you like math. If you don't like math, she's the worst math teacher you'll ever have. Because now. Anyways, here's the whole log is bay thing. Log is bay. The B stands for base. A stands for answer or argument. E stands for exponent. And there's your equivalent form. B to the E equals A. Now, most of the notes you do today is about conversion. Convert the following logarithm equations to exponential form. So you have log, and I'm reading this to you, log base 3, argument or answer 81 equal to 4. Line things up. Look above. Actually, look over here to your left. What's that little 3 represent? Is it a base, an argument, or an exponent? It's a base. What's the 81 represent? It's A. And 4 is E. Log is bay. Bay is French for what? Poop. That's right. Wow, who said that? Dylan. Bay is French for poop. All right, we're going to rewrite this. What would your base be? 3. What is it raised to? The 4th power. What must that equal? Is that true? Is 3 to the 4th 81? You know, that's kind of how you check yourself when you're rewriting little things. You have to rewrite a true statement. All right, C, log base 14, argument 1 is 0. What's the 14 represent, Spencer? Base, an argument, or an exponent? Let me reread this to you. Log base 14, argument 1 equals 0. Log base 14, argument 1 equals 0. What's the 14 represent? I swear every time I read these things, I'll read it just like I did. Log base 14. 14 is your base. A for argument or answer. What's A? 1. E has to be what's left, right? It's kind of funny we call the answer or the argument the 1, but then you have this equal. You think that the guy on the other side would be the answer. It's not the way it works. Your exponent is 1 or 0. The goal here is to spell bay in that order. When you're working with a logarithm, you literally spell bay. B-A-E. It's not 14 in the first. What's the base? Base is 14. What's its exponent? 0. And what does that have to equal? That's why I'm writing all the letters down. Jump to D. Now, I would read that log base 1/2 of 32, or answer argument 32 equals -5. Dylan, what's the base? 1/2. It's the first number you encounter in a logarithm. Austin, what's the answer or the argument? 32. The next number you encounter. Anna, what's the exponent? -5. And then I just have to write it out and see if it makes sense. What would this 1/2 power be raised to? It would be raised to the -5th. And what would it have to equal? That's a little harder to prove in your head. But if you have a fraction to a negative power, you flip the fraction and what happens to the exponent? It becomes positive. This is actually 2 to the 5th. Is 2 to the 5th 32? Yeah, if you don't believe me, type in a calculator. It'll tell you it's 32. You have to write true statements. So that's converting from a logarithm into an exponential form. And now we'll go the other way around. Actually, these are evaluating. Never mind. Evaluate the logarithm. Find some number y that equals the log. It's a big deal on all of these to ask yourself what it's asking first. This logarithm right here is asking us what power of 4 generates a 64? 3. I already know that y is 3. Now what I'm asking you to do is always actually solve it. What you do is you'd say log base 4 of 64 equals y. Now convert that thing into exponential form. What's the base? 4. What's the exponent? Y. What would it have to equal? Maybe if you saw it in that form, it'd be more obvious. But is y 3? Because 4 cubed is 64. And asking yourself what it's asking is just as important as knowing how to solve. Zoomed in as far as I can zoom in. Log base 5, argument of 2/10. What is that asking you? That's exactly what it's asking you. What power of 5 is 2/10? Is 2/10. Anybody know that? That's correct. That's correct. Y is -1. Who said that? Good job, Sean. That's correct. Now, if you rewrite it as an exponential function, it might make more sense. You say it equals y. Your base here is 5. 5 to the y equals 2/10. I wrote it out as 2/10. I don't know if it will or not. But Sean was correct. He said negative first power. Because you have 5 to the -1. That means 1 over 5. And 1 over 5 equivalent to 2/10? Yes, because 2/10 reduces down to 1 over 5. All right, we'll jump down to D. This is log base 36 equals 6. What's it asking? What power of 36 equals 6? Anybody know the answer to that? I'll give you a big hint. The square root of 36 is 6. 1/2. Power is 1/2 because the square root is the half power. And I'm not going to write that out and solve it by hand. But if a kid will learn how to read a logarithm and actually try to understand what it's asking, they'll do a lot better than a kid who just punches buttons on a calculator all day long. They will. All right, common logs. A log with base 10. The 10 is understood. You'll notice every logarithm I've done so far, we've had a log with a base, that little subscript. Well, you don't have a subscript on log base 10. You don't say log base 10 of x, you just write log of x. Look at your calculator. It has an LOG button. Doesn't say a base, does it? Calculator log button has an understood base of 10. Then we have the natural logarithm. It's a logarithm of base e. It actually does exist on your calculator. We don't write log base e of x, we write ln. It's called the natural log, but we write ln. It's log natural. It's French. Euler, remember E, Euler's number? He was French. That's one of your Romantic languages, just like Spanish. They're all cousins. Isn't everything backwards in Spanish?
Kind of, yeah.
Well, that's kind of the same thing here. They put certain words for others compared to us. So it's the natural log of x. Does your calculator have that button? If you don't have a calculator, you never know. But yes, it does. It's right under log. ln. All right. Do some easy stuff. Evaluate common and natural logs. The way you traditionally round these to 4 decimal places, that's the way I was taught. That's the way you'll do it too. Log, understood base of what? 10 of 9. That's as simple as punching a button on a calculator. You should probably press that button at least once in your life. Pay dividends when you take a test. At least you'll know where it's at. about 0.95424. Logarithms are the exact inverses of exponential functions. So if you take 10 and you raise it to that decimal, you'll get 9. Anyways, the answer is 0.9542. Natural log of 3. Well, there's an LN button on your calculator. Just press it. 1.0986, because we round how far? 4. That's tradition, kids. But your generation seems to say the heck with tradition. I wouldn't suggest you do that in a math course, kids. Well, I wrote 2, but it identifies as 3 because that was the right answer, right? Now, I'm going to fill in some here. Remember I told you couldn't do this in a calculator just yet? Your calculator, and there is a way to get pull-up change of base on a calculator, but I'll never teach it because it doesn't do you any good long term. The log button on your calculator has a base of what? 10. That initial example that I wanted us to do in a calculator has a base of what? 4? Well, here's where you learn how to do that. It's called change of base formula. There's 2 ways of using it. The way I do in class will always be to use ln. A log base b, argument a, is equivalent to the natural log of a over the natural log of b. Or log a log b. I will always use this. Always. You will never see me type log a over log b. There's a reason for that. It's because I teach the stuff after this course, and that stuff's more important. So let's go back and answer that one question we couldn't answer. I think we came to a consensus it was over 4, right? Let's see what it is. How can I evaluate log base 4 509 in calculator? Not ln4. I mean, that's half of it. You're over the natural log of 4. Notice how that 4 is down low? The ln of 4 is down low. ln of 509. Notice there's a natural log in both numerator and denominator. It's not the natural log of 509 over 4. ln of 509 over ln of 4. I said it would be a little over 4. Oh, it's actually close to 4.5. It turns out if you take 4 and you raise it to this decimal, and I'm just going to type down 4 digits of it, I'm not going to type down all of it. You get really close to 509. I rounded too, by the way. That's how it works. All right, so there's a simple using change of base. Let's only do example B. Evaluate log base 2 of 14. We'll use ln. ln of what over ln of what? ln of 14 over ln of 2. That is not the natural log of 7. There's a natural log of something divided by the natural log of something. So ln 14 sitting over ln 2, and you should be playing along. That's how it works. You know this by now. 3.8074. Tradition is 4 decimal places. You know, you don't learn how to build a birdhouse by never using a saw, kids. What do we got next? Some simplification? I might want to... Oh yeah, this is the easy day on logarithms. Although this part is not too easy. Simplification the following expressions. 10 raised to the log of 4. What we're going to do is we're going to set equal to y, and then we're going to probably rewrite. So I'm going to say that equals a y. Hold on a second. Is 10 a base? Bases have what? Exponents. Bases have exponents.
What's that word next to y?
Equal? Oh, set equal to y, and then rewrite. Bases have exponents. 10 is a base. What is 10's exponent? Log 4 is an exponent. And the answer is y. Those are your 3 letters. This is an exponential function that you can rewrite as a logarithm. See what happens. All right, so this 10 is a base. We'd have log base 10. What goes in parentheses? No. Let's go back over this. Log base b, argument a equals e. Log base b, argument a equals e. Y equals log 4. Now that log 4 has an understood base. What is it? 10. I don't really know how to teach this other than the fact that the answer is staring right at you. What is it doing?
Log 4, and then you have your equal sign.
A, E. We're using letters B, E, and A. What's y have to be? Y is 4. Because these pieces match. It's about visually making it look the same. It's the sort of solving you can do. All right, we'll do another one of those because I know those are tricky because they're actually teaching you something that you kind of build on tomorrow. Tomorrow's lesson is going the other way around with these things. We have a log base 5 of 25 to the x. This is kind of interesting. This is written out in a different form. Your 5 would represent what? Base. The 25 to the x would represent what? A. And we'll set it equal to a y, and the y would be an e. So rewrite it as an exponential function. 5 to what power? 5 to the y would have to equal 25 to the x. Is 25 a power of 5? Yeah. 25 is 5 to what power? 5 to the y equals 5 to the 2x. What's y have to be? 2x. That one kind of stinks that you don't have a number. You know, example A, I could have checked in a calculator. I could have typed 10 rooftop log 4. And it would have told me 4. There's actually a theorem in most math books about this. But what happens is you got that 10 log base 10 of 4. They cancel each other out and free up to 4. That's what's happening on that one. And I'm going to skip C. Find the inverse of an exponential or logarithmic function. That's not too hard to do. I've got off to the side here that logarithms and exponential functions are inverses of each other. So we're going to do the first step. We're going to swap x and y, and we're going to solve by converting to a different form. So Let's do this one. Y equals 4 to the x minus 3 plus 5. First step of inverse is always swap x and y. What's that y become? Becomes an x. 4 to the y minus 3 plus 5. Now what we're going to do is we're going to convert this thing. This is what we call an exponential function. We're going to convert it to a logarithm. We're using the idea of log is bay. A logarithm, base b, argument a equal to some e, has an equivalent inverse in the form b to the e equals a. But I want you to notice that the logarithm is isolated. Over here, this is isolated. The base with the exponent is isolated. So we have to isolate the base with the exponent. So what do we have to isolate? How do we do that? Subtract 5. X minus 5 equals 4 to the y minus 3. Now, it's a little out of order compared to some of the examples that we've done so far. You could flip it around. That'll make it easier on some kids. 4 to the y minus 3 equals x minus 5. Rewrite it. Flip it. It's the same thing. You just jumped equal on both sides. All right? What's your base? 4. What's your exponent? E. Y minus 3. And what's the argument or the answer? Well, that's the equivalent logarithm. Logarithm. Base what? 4. Argument. X minus 5 equal to y minus 3. Now, is this thing solved for y yet? What are you going to add? Add 3. Can you add that 3 to the stuff in parentheses? No, that's prison. Now, that would isolate y. And when you're done, y is supposed to be replaced with that funky function notation. F to the negative what? First power. I'm not going to do the last one. I want to get through at least one graphing problem. Graph y equals log base 2 x plus 3 plus 2. This won't be too bad, I promise you. How's it telling you to shift? Left 3, up 2. Left 3, up 2. So I go left 3, and I rise 2. Now I've got a starting x value. I only went of negative 3. Go back 2. Go forward 2. Now, when we type this in a calculator, we're going to have to use change of base. Y is the natural log of x plus 3, sitting over the natural log of 2, and then add 2. Remember change of base? You look so angry at me for teaching you logarithms right now, it's ridiculous. This has a base of 2, your calculator has a base of 10, right? We use change of base form. So I'm going to start off by taking a negative 5, storing it into x. Then I'm going to type in what I wrote. Natural log of x plus 3, sitting over the natural log of 2. I got to close up here, and then plus a 2. Oh, I got a non-real answer. Anybody else get a non-real answer? There's a reason for that. Well, I didn't have time to finish, so why don't you try the homework and I'll address it tomorrow. You ask me about a graph problem tomorrow, I'll tell you why. Or maybe you could Google it. You guys live in a special generation. All of our knowledge is out there on the internet, except for what's being censored. They're not censoring math at the moment. Wait 20 years. Wait 20 years. Wait 20 years and start censoring that too. I mean, it doesn't hurt people's feelings. Can't have that.
Good. Chill.
That's